Hi everyone. So we are working on function notation today. So it's a quick review of what we learned last week. All right, so our main idea is function notation. So equations that represent functions are often written in function notation. So y equals 4x minus 1 becomes f of x equals 4x minus 1. This is read as f of x equals dot dot dot, whatever else is equal, it equals. All right, so x is the input and f of x is the output. All right, so when you're evaluating functions, function notation is especially useful for finding a value in the range that corresponds to a certain domain value. So for example, if you're given that f of x equals 4x minus 1, you're going to find f of negative 7. So f of negative 7 is actually just going to be equal to 4x minus 1, but your x this time is negative 7 minus 1. All right, and then you'll just simplify. So 4 times negative 7 is negative 28 minus 1 equals negative 29. And so then you would write f of negative 7 equals negative 29. And that's your solution. All right, so let's go ahead and practice with some examples. All right, so number 1, we are evaluating each function for the given value. So we have f of x equals x plus 7, and f of 5 is what we're finding. So f of 5 is going to be equal to 5 plus 7. Well, 5 plus 7 equals 12. So f of 5 equals 12. That's your solution. Next, we have g of x equals 3x minus 8, and we're evaluating g of negative 3. So g of negative 3 is going to be equal to 3 times negative 3 minus 8. 3 times negative 3 is negative 9 minus 8. So g of negative 3 equals negative 17. And you are allowed to use a calculator for your functions. So if you want to go ahead and evaluate that way, you can. That is perfectly fine. All right, number 3, h of x equals 2/3 x minus 1, and we're evaluating h of 9. So h of 9 is going to equal 2/3 times 9 minus 1. Well, 2/3 of 9 is 6. So I'll have 6 minus 1. So h of 9 equals 5. Moving on to number 4, we have f of x equals x squared minus x, and we're evaluating f of negative 4. So f of negative 4 is going to equal negative 4 squared minus negative 4. Okay, so we'll have negative 4 squared is 16, minus negative 4 is really plus 4, so that should equal 20. F of negative 4 equals 20. Next, for number 5, we have f of x equals negative x squared plus 6x minus 4, and we're evaluating f of 5. So f of 5 is going to be equal to negative 5 squared, and I can just put it there if I want, plus 6x, which is our 5, minus 4. So negative and then 5 squared is going to be negative 25, plus 6 times 5 is 30, minus 4. All right, this is negative 5, or I'm sorry, it's positive 5, and then I have 5 minus 4, so that equals 1. So f of 5 ultimately equals 1. Next, I have g of x equals negative 1/2 x plus 9, and we're evaluating g of negative 8. So g of negative 8 equals negative 1/2 x, which is negative 8, plus 9. So negative 1/2 times negative 8 is positive 4, plus 9 is 13. Okay, so g of negative 8 equals 13. And next we have number 7, f of x equals 2x squared plus 4x minus 9, and we're evaluating for f of negative 5. So we'll have f of negative 5 equals 2 up against our x squared plus 4 of negative 5 minus 9. So you first need to do negative 5 squared, and that is 25 times 2 is 50, plus, and I'm really doing 4 times negative 5 is negative 20, and then minus 9. So 50 minus 20 is 30, minus 9 is 21. So f of negative 5 is positive 21. And finally, I have g of x equals the absolute value of x minus x squared. And I'm solving for g of negative 7. So I'll have g of negative 7 equals the absolute value of my x, which is negative 7, minus negative 7 squared. Okay, I'll leave those absolute value bars alone. So I've got negative 7 minus negative 7 squared, and negative 7 squared is 49. And so I'm doing negative 7 minus 49 is negative 56. And the absolute value of negative 56 is just 56. So g of negative 7 equals 56. All right, we'll move to that back page, or this next page. All right, so you have f of x equals 4x plus 11, and now you're going to be inputting c plus 7 in for x. So you're still going to do the exact same motions of what we've been doing, but this time instead of having an integer for our input, we'll have an expression, and that's perfectly fine. So f of c plus 7 is going to equal 4 times our x, which is c plus 7, plus 11. All right, so when you have this, you need to then distribute. So distribute the 4 to the terms in your parentheses. So we have 4 times c is 4c, plus 4 times 7 is 28, plus 11. So then we just simplify. So f of c plus 7 is actually just going to be equal to 4c plus 39. All right, moving on. H of x equals negative 9 minus x, and our x this time is 2k minus 5. So you plug that in, same thing as what we just did. So h of 2k minus 5 is equal to negative 9 minus our x, which is 2k minus 5. All right, so you substitute again. Or not substitute, distribute, sorry. So you'll have negative 9 minus 2k plus 5. So h of 2k minus 5 is going to be equal to negative 2k, and I'm just putting my variable term first, minus 4. And that is our solution here. All right. For these next 6, you're going to be using the functions to the left to answer these. So we're going to do f of 4 plus 9. So we'll find the function of 4. So we'll look at the f function, and we have the f function is 8 minus 3x, and our x is 4, and then we'll add 9 to that. That's just coming right there. Okay, we're getting it from there. All right, so do order of operations. 8 minus 12 plus 9. 8 minus 12 is negative 4 plus 9 is 5. Our solution here is 5. Number 12, we have negative 2 times our g of 5, or g of negative 5. So look at the g function. So we're looking at g function this time. And we have our g function is x squared, so that's negative 5 squared, plus 2 times our x. And then you just solve like normal. So you have negative 2 times all of this stuff. So let's do this first. So we'll have negative 2 times negative 5 squared is 25. And then plus your 2 times negative 5 is negative 10. Well, 25 plus negative 10 is 15. Times negative 2 is negative 30. Okay, number 13, g of 4 plus g of negative 1. So we're still on that g function. So g of 4, plug it straight in, x squared plus 2 times our x, plus x squared again, which is negative 1 squared, plus 2 times our x. All right, so we've got 16, bye y'all. So we've got 16 plus 8 plus 1 minus 2. So 16 plus 8 is 24, plus 1 minus 2. That's 25 minus 2, which is 23. All right, and then we have 14, 15, and 16 are all the same type of thing. So let's go ahead and do that. So we'll have 3 times our h squared, h of 2. H of 2, I'm on my h function this time, or right here I'm on my h function. So I'll have negative 5 times my x, which is 2, and then minus 1, and then I'll subtract my f of negative 9. So I'll have 8 minus 3 times negative 9, and I'll simplify. So I'll have negative 5 halves times 2 is negative 5, minus 1 is negative 6. So I've got 3 times negative 6, minus 8 times negative 3 times 9. So negative 3 times 9 is negative 27, and 8 minus negative 27. Or I'm sorry. Yeah, so it'll be 8 minus negative 27, so it's 8 plus 27, and that's 35. So then I've got negative 18 plus 30 minus 35, sorry about that, and that's going to be equal to negative 53. All right, and finally I've got to solve for x this time, so I'll use my function f of x equals 8 minus 3x. So 8 minus 3x is going to be equal to negative 13, and I just solve for x. So I'll subtract 8 from both sides. So negative 3x equals negative 21. Divide by negative 3 on both sides. X is going to equal to 7. That's my solution here. And then finally, for number 16, I do the same thing for the h function. So I've got negative 5 halves x minus 1 equals 39. So I'll add 1 on both sides. Negative 5 halves x is going to equal 40. Is going to equal 40, and then I'll divide both sides by negative 5 halves. So x is going to be equal to 40 divided by negative 5 halves. And I got 40 divided by negative 5 halves. And I got negative 16. All right. And we are almost done with our notes for today. So number 17, anthropologists use the length of certain bones of the human skeleton to estimate the height of the living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, the function h of x equals 61 plus 41 plus 2.32x can be used. So you'll just find h of 46 and explain its meaning. So remember that the meaning is going to be the female's femur length. Okay. So it's going to be the height. So all of this is to find the height of the person. So once we find h of 46, it's going to give us her height. Okay, so we'll have h of 46 equals 61.41 plus 2.32 times 46. And you can plug that straight into your calculator and you'll get your answer. 6.41 plus 2.32 up against 46. And that's going to be equal to 168.13 centimeters. So that means the female's height is 168.13 centimeters. Okay, And then finally, we have to evaluate functions when given a graph. And these are the easiest things ever, and I love them. So all you have to do is you're looking at the function that you're given. So look at the graph, and like for A, if it says f of -3, I'm going to go to my graph where x is -3. I'm going to trace it up to the graph and see where it crosses. So it crosses at +2, if you can see that. Okay, so f of -3 just equals 2. And I'll do the same thing for the others. So f of 1, I'll go to where x equals 1 and I'll trace it up. My y is also 2 there. Okay. F of 0, when x is 0, I go up and I see my y is actually 5. And then f of 2, when x is 2, I scroll down, or I go down to my graph, and that's at -3. And I do the exact same thing for this last one. F of -4, when x is -4, I go over here and go up to my graph. My y is 2.
Oh my God.
F of 0, when x is 0, my y is also 0. F of 2, when x is 2, my y is -2. And finally, f of 5, when x is 5, 1, 2, 3, 4, 5, my y is also -1 here. All right, and that is it for our notes for today. So you're going to go with your homework and use your notes to help you answer all these problems, and we will review this in class. Thank you.